How exactly did humanity's greatest space telescope go blind? Hubble was not a prototype. It was not some cheap experiment. It was the eye we sent above Earth. Its mission was simple: escape the atmosphere, look deeper than any telescope before it, find galaxies, newborn stars, and ancient light, show us parts of the universe we had never seen. But when the first images came back, something was wrong. They were not sharp. They were not the breathtaking windows NASA expected. They looked soft, blurry, and strangely broken. And that was the nightmare. Hubble had reached space. Its cameras were alive. Its systems were responding. It was orbiting Earth exactly where it belonged. But the universe still looked out of focus. So what happened? Was the telescope shaking? No. Was Earth blocking the view? No. Did the main camera completely fail? Not exactly. The problem was far deeper than that. It was inside Hubble's own eye. The main mirror, the one built to catch ancient starlight, had the wrong shape. Not by much. Not enough for a human eye to notice. But in space optics, tiny errors are catastrophic. A mistake smaller than a dust-sized detail can smear light from entire galaxies. And now that mistake was circling Earth at orbital speed. But here is the real problem. Hubble was not sitting in a lab anymore. You could not open a drawer and swap the mirror. You could not pull it down for repairs. You could not treat it like a broken camera. It was hundreds of miles above Earth. So how do you fix a telescope in orbit? How do you repair a flaw buried inside its optical system? And how small does an error have to be before it makes the entire universe blurry? To answer that, we have to go back. Before the repair, before the rescue mission, before Hubble became a legend, we have to start with the moment its greatest promise became NASA's most public failure. Before Hubble became a legend, it was a promise. Not just another telescope, not just another machine in orbit. It was supposed to change human vision forever. Ground telescopes were powerful, but they had a problem. They looked through Earth's atmosphere. That atmosphere bends light. It smears stars. It shakes distant galaxies into soft glowing blobs. So NASA made a bold choice. Put the telescope above the atmosphere. Take the eye of science into space. Let it see without air in the way. And that is why expectations were enormous. Hubble was not launched to be average. It was launched to be historic. Scientists expected razor-sharp views of the universe. They wanted newborn stars. They wanted deep galaxies. They wanted structures no human had seen clearly before. The idea was simple. If Earth's air was the problem, space was the solution. But what happens when the telescope reaches space and the image is still wrong? That was the first warning sign. Hubble was alive. Its computers worked. Its cameras responded. It was not tumbling out of control. It was not silent. It was sending data back home. But the data did not match the dream. The pictures looked soft. The stars did not focus cleanly. The light was there, but it was spread out. The telescope could see the universe. It just could not see it clearly. So the question became terrifying. The camera still worked. Why was everything blurry? Maybe the telescope was vibrating. Maybe the sensors were misaligned. Maybe the guidance system was drifting. Maybe the problem was somewhere small and fixable. That was the hope. Because if the issue was only software, it could be corrected. If it was only pointing, it could be adjusted. If it was only calibration, engineers could tune it from Earth. But then the investigation moved deeper. The problem was not just a bad setting. It was not a simple camera issue. The light itself was arriving wrong. Somewhere inside Hubble, starlight was being bent incorrectly. That meant the issue was optical. And the most important optical surface was the main mirror. The mirror was supposed to collect ancient light. It was supposed to bring that light into perfect focus. But instead, it was sending that light slightly off target. And this is where the nightmare becomes almost unbelievable. The mirror was not wildly broken. It was not cracked. It was not shattered. It was not covered in dust. It was simply shaped wrong. Not by inches, not by a visible dent. The error was incredibly small. To a normal person, it would look perfect. To space optics, it was catastrophic. Because Hubble was built to handle light with extreme precision. A tiny shape error can spread a single star. It can turn a sharp point into a fuzzy smear. And if one star is smeared, everything is smeared. Galaxies lose detail. Nebulas lose structure. Distant objects become harder to measure. So now NASA had a billion-dollar eye in orbit, and that eye had the wrong prescription. But how did this happen? If the error was so important, why was it not caught? That question made everything worse, because Hubble had been tested on Earth. The mirror had been measured, the systems had been checked, the mission was not rushed like a school project. This was one of the most serious science machines ever built. Yet one tiny optical mistake passed through the system, and once it reached space, the mistake became public. Now the problem was no longer just technical. It became symbolic. Hubble was supposed to show humanity the universe. Instead, it showed humanity a blurry mirror. Headlines did not care about tiny tolerances. The public did not care about optical geometry. They saw the result. The greatest telescope ever launched could not focus, and every new image made the failure harder to hide. But the hardest part was still ahead, because Hubble was not sitting in a clean room. It was not bolted to a workshop table. It was flying above Earth. That changed everything. You could not ship it back overnight. You could not unscrew the mirror with normal tools. You could not ask technicians to step inside it. Every possible repair became a space mission. To fix the mirror, engineers first needed the exact error. To find the exact error, they had to reconstruct the light path. To reconstruct the light path, they had to model how starlight moved through Hubble. Then they needed a correction system. But that system had to fit inside the telescope. It had to survive launch. It had to work in orbit. And it had to be installed by astronauts. That created the next problem. Astronauts are not working in a normal garage. They work in bulky suits. They work with limited movement. They work while floating. Every tool must be controlled. Every panel must be handled carefully. Every step must be rehearsed. Because in space, a simple repair becomes a chain of risks. And there was another pressure: time. Every day Hubble stayed blurry, trust kept falling. Scientists were waiting. The public was watching. NASA had to prove the telescope was not a lost cause, but they could not just try something random. If the repair failed, the embarrassment would grow. If the fix damaged another system, the mission could get worse. So this became a strange rescue. Not a rescue of a person, a rescue of human vision, a rescue of a machine built to see history. Hubble was still alive. It was still orbiting. It was still full of potential. But it could not fulfill its mission alone. And that left one impossible question. You cannot replace the main mirror. What do? You do not fix the eye itself. You fix the way light reaches the eye. You give the telescope something it never expected to need: a correction, a second optical system, a pair of glasses built for space. But here is the twist. Hubble did not need more light. It was already catching light from deep space. It did not need stronger cameras. The cameras were waiting for a clean image. The real problem was focus. Hubble was like a giant eye with the wrong prescription. Think of the main mirror like the front of an eye. Its job is simple but brutally precise. It collects light from distant objects. Then it bends that light into one sharp point. Every ray lands together, you get clarity. Stars become sharp. Galaxies reveal shape. Dust clouds reveal structure. But if the mirror shape is slightly wrong, everything changes. Light still enters the telescope. The universe is still there, but the rays do not meet perfectly. Some land too early. Some land too late. The image does not disappear. It spreads out, it becomes soft, it becomes smeared. That is why Hubble's failure was so strange. It was not blind in the normal sense. It was not dead. It was not empty. It was seeing the universe every second. It just could not place the light correctly. And in space science, that is enough. A tiny focus error can erase fine detail. It can turn discovery into disappointment. So how do you fix that? The obvious answer sounds simple. Replace the mirror. But that was almost impossible. The mirror was deep inside Hubble. It was the heart of the whole telescope. Swapping it in orbit would be a nightmare. Bringing Hubble home was not the easy answer either. So engineers had to think backwards. If the mirror made one kind of error, maybe another optic could make the opposite error. Not a random mistake. A perfect, controlled mistake. One that bent the light back into place. That was the genius. They would not erase the flaw, they would cancel it. It is like giving glasses to a nearsighted eye. The eye still has the same shape. The problem is not magically gone, but the lens changes the path of light. It corrects the image before the brain receives it. Hubble needed the same idea. Not ordinary glasses, not a tiny fix. A precision optical correction system built for space. And that is the wild part. The fix was based on admitting the mirror was wrong. Engineers had to measure the mistake exactly. Then they had to design an opposite optical shape. If the correction was too weak, Hubble stayed blurry. If it was too strong, Hubble stayed blurry. If it was misaligned, the mission failed again. But how do you install glasses on a telescope in orbit? That is where the rescue became real. The correction system had to be launched from Earth. It had to survive the violence of launch. It had to reach Hubble in space. Then astronauts had to install it by hand, and this was not like repairing a laptop. Hubble was flying above Earth. Every tool had to be secured. Every movement had to be planned. Every bolt mattered. Astronauts would be wearing pressurized suits. Their gloves were bulky. Their visibility was limited. Their bodies were floating. Even simple actions became slow and difficult. First, the shuttle had to reach Hubble. Then it had to approach safely. Then Hubble had to be captured and stabilized. After that, astronauts had to open the telescope. Opening it was only the beginning. They had to remove old equipment. They had to slide new hardware inside. They had to connect delicate systems. and they had to do it outside Earth. But every solution created another challenge. The correction system had to fit in available space. It had to work with existing instruments. It had to survive extreme temperature changes. It had to stay aligned after installation. It had to turn a failed image into science. This was the real rescue mission, not rescuing a person, rescuing human vision. Hubble was not abandoned. It was not written off as a mistake. The entire plan said one thing. If the telescope still had potential, they would save it. Then came the moment that mattered. After the repair, Hubble looked again. The light entered the flawed mirror. Then it passed through the correction system. The new optics bent the light back. The scattered rays started meeting properly. The blur began to disappear. And suddenly the story changed. Hubble was no longer just a failure. It became a comeback. The same telescope that disappointed the world began proving itself. Its images became sharper. Its vision became powerful. The machine once mocked for being blurry became iconic. But the deeper lesson was bigger than Hubble. This was not just about one telescope. It was about how advanced systems really work. A billion-dollar machine can fail from one tiny flaw. But it can also be saved by understanding that flaw. That is the part most people miss. Science is not only about perfect launches. It is about diagnosis. It is about correction. It is about facing the error directly. Hubble became legendary not because it was flawless. It became legendary because humans fixed the flaw. And that makes the story even more powerful. The telescope did not need a new soul. It needed a new way to see. NASA did not replace the heart of Hubble. It changed the path of the light. A tiny error had blurred the universe. A tiny correction brought it back. But that leaves a bigger question. If one small optical mistake could nearly ruin Hubble, what about every other machine we trust? What about the next telescope? The next spacecraft? The next giant system built on tiny tolerances? Because Hubble was saved. But the lesson did not end there. And this is why Hubble matters. It was built to see the farthest things. But it almost failed because of something incredibly close. Not a distant galaxy, not a cosmic storm, not some unknown force in space. The problem was inside its own eye. That is the real lesson. The most advanced machines are not magic. They are still built from parts. They depend on measurements. They depend on alignment. They depend on tiny assumptions being exactly right. And when one tiny detail is wrong, the whole system can suffer. But Hubble's story is not just about failure. It is about what happens after failure. NASA could have treated it like a disaster. The public could have remembered it as a mistake. Scientists could have moved on. But instead, engineers studied the flaw. They mapped the problem. They built a correction. Then astronauts carried that correction into orbit. That is what changed everything. Hubble was not saved because it was perfect. It was saved because humans refused to leave it broken. And once it could finally focus, it became something greater. Not just a telescope, a symbol of recovery. A machine that proved mistakes can be repaired. But here is the uncomfortable part. Hubble was not the last giant system with a hidden weakness. Every future telescope has tolerances. Every spacecraft has assumptions. Every powerful technology depends on small details working together. And the next tiny flaw may not look dangerous at first. So what is more frightening? A machine that fails completely? Or a machine that works almost perfectly, except for one hidden error at the worst possible place? That is why this story still matters. Because Hubble did not just reveal the universe. It revealed something about us. We build impossible machines. We make impossible mistakes. Then we try to fix them. So if one tiny error could blur the universe, how many hidden flaws are waiting inside today's greatest technologies? And if Hubble could be saved, does any great failure truly have to be the end?